Hello. So these are 12.4 notes. We're going to look into measures of dispersion. And before we kind of go in it, we're going to look at the definition of range. So range is the difference between the highest and the lowest values. It indicates the total spread of the data. Range equals highest value minus lowest value. So let's look at the data over here. So we need to calculate mean, median, mode, mid-range, in range. So let's go ahead and start looking at these. So our mean, of course, we're going to add 1 plus 1 plus 2 plus 2 plus 3 plus 5 plus 5 plus 5 plus 5 plus 7 plus 8 plus 8 plus 8, 9 plus 9, and equals. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. So we're going to divide this by 14, and our mean is 5. Then let's look at median. So we have 14 numbers. So 1, 2, 3, 4, 5, 6, 7 is right here. 1, 2, 3, 4, 5, 6, 7. So our median is in between these two numbers, which would make it 5. Mode, we have 2 1s, we have 2 2s, we have 1, 2, 3, 4 5s, 2 8s, and 2 9s. So our mode is going to be 5 because that's the one that has the most. Mid-range is going to be 9 plus 1 divided by 2. So the highest plus the lowest divided by 2. So 10 divided by 2 is 5. So our mid-range is going to be 5. Now let's look at the range. So range is highest value minus lowest value. So we're going to take 9 minus 1, that equals 8. Next one. Let's calculate the mean again. 1 plus 3 plus 4 plus 4 plus 4 plus 5 plus 5 plus 5 plus 5 plus 6 plus 6 plus 6 plus 9. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Divided by 13 is 4.8. Now we can round that to 5. Our mean here, so we had 13 numbers. So 1, 2, 3, 4, 5, and 6. So this number is the median, which is a 5. And mode, if we look at these numbers again, we have 3 4s, we have 3 6s, but we have 4 5s. So it is 5. Mid-range, 9 plus 1 divided by 2, which we just did here, is 5. The range is going to be the same because the highest and the lowest number remains the same. That doesn't change, so that's going to be an 8. Okay, next one. So 1 plus 4 plus 4 plus, how many 5s do we have? 1, 2, 3, 4, 5, 6, 7, and 8 5s. So I'm going to do 8 times 5. I'm going to be lazy. Plus 6 plus 6 plus 9. I could have done 2 times 6 there as well. Divided by, and I think we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. Yes. 14. And our mean again is 5. Our median, so 1, 2, 3, 4, 5, 6, and 7. Again, it's in between 2 5s, so the median is a 5. And if we look at how many fives we've got, 1, 2, 3, 4, 5, 6, 7, 8. So our mode is 5. Mid-range, we still have our highest and lowest numbers as 9 and 1. So that's going to be a 5. And range doesn't change either because of the highest and lowest numbers are the same. Okay, so what we're going to do here is we're going to graph each of these on a number line and look at how they are different. Because if we look at these numbers here, there's really not a difference in any of them. So let's go ahead and do our first number line. So I'm going to do from 0 to 10. And I'm actually going to draw all these number lines at the same time. So hopefully they are pretty much so that I've got the numbers in pretty much the same places, because we do want to kind of compare them. See where the numbers are. So the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Same thing here. And of course now I didn't leave a lot of room in between these two. Oh well, we'll figure it out. So on this first one, we have 2 1s, we have 2 2s, we have a 3, we have 1 2 3 4 5s, 1 2 3 4, 1 7, 2 8s, and 2 9s. On this next one, we have 1 1, 1 3, 1 2 3 4s, 1 2 3 4 5s, 3 6s, and 1 9. Last one, we have 1 1, 2 4s, 1 2 3 4 5 6 7. Hold on. 1 2 3 4 5 6 7 8 5s. That's what I thought. 1 2 3 4 5 6 7 8. And then 2 6s and 1 9. So if we look at the number lines, though, we can see that this first one is a lot more spread out than this one where, we have the 5 going into the next number line. So one way, since we can't get anything, these all look the same. One way to figure out the difference between these is a measure of dispersion called standard deviation. So it measures how much the data differs from the mean. So our mean here is 5 on all of these, but how much does it differ from that? So the formula to calculate that looks like this. So you might have seen some of these already on, we did this one, that is a mean, that line on the top. The sigma here means that we are adding all these. So let's look at how we're going to use this, or how we use that formula. How do we calculate a standard deviation? So we're going to go ahead and here on number 1, find the range in standard deviation for the following data set. Round to the nearest thousandth if needed. So this is our data set, and it is already in an order. So we're going to do our range, which was the highest minus the lowest. So 6 minus 0, and our range is 6. Now, to calculate this, or use this formula here, what we're going to do first, before we do anything else, we're going to calculate the mean of the set. So this part right here. So mean of the set is going to be 0 plus 1 plus 3 plus 4 plus 4 plus 6 divided by, how many numbers do we have? 1, 2, 3, 4, 5, 6. Yes. So our n in here is 6. We're going to need that n in that standard deviation as well. Okay, so let's put this in a calculator. 0 plus 1 plus 3 plus 4 plus 4 plus 6. And I know that our calculator can calculate mean, but you're going to have to show the work on the test, how to do it. So we're not using the calculator. It can actually calculate the standard deviation as well, but we're not using that either. You're going to, again, you need to show the work where you get your answer from. Okay, next what we're going to do here is we're going to make a table. So here, we're going to list our x. Then we're going to subtract the mean from the x. And then we're going to square that number. So we have 0, 1, 3, 4, 4, and 6. We're going to subtract 18 from this. 0 minus 18 is negative 18. 1 minus 18. How did we get 18? We didn't divide this. I was like, where? That doesn't make sense. Yeah, we forgot to divide this by the 6. I wrote it here, but I didn't divide it. Yes, our mean is 3, not 18. I was like, that number does not match this. So here we're making corrections on here. So these are, so that one's not correct. So it's 0 minus 3, negative 3. It is 3, the mean. 1 minus 3 is a negative 2. 3 minus 3 is a 0. 3 minus 4, now I'm doing it upside down or the other way. So it has to be this minus the mean. 4 minus 3 equals 1. 4 minus 3, the same thing, equals 1. 6 minus 3 equals 3. So now if we have done this correctly, if we add all of these, negative 3 plus negative 2, which is negative 5, and then plus 1 plus 1 plus 3, we should get a 0 here. Unless we have rounded something. But this number, if we add all these, it should be close to a 0. Okay, next, we're going to take the answer here and square it. So that means negative 3 squared is 9. Negative 2 squared is 4. 0 squared is 0. 1 squared is 1. 1 squared is 1. 3 squared is 9. And now we're going to add these numbers. So we have 9 plus 4 plus 1 plus 1 plus 9. So 1 plus 9 is 10. 1 plus 9 is 10. So that's 20 plus 4 is 24. So these numbers add up to 24. Now we're going to take that formula. So standard deviation is our sigma x minus the mean of x squared divided by n minus 1 and square root of this. Well, guess what? We already calculated this part here. That is our 24. So this is 24. We don't need to do anything. We did it right here. Then we're going to divide, and this is all in a square root. We're going to divide by n, which is 6, minus 1. So 24 divided by 6 minus 1 is 5, and a square root of that. 24 divided by 5 equals, and then the square root is above the x to the power of 2, so second square root, and now I need that answer. So I'm going to hit the second answer and equal, and I get 2.191. So we have an 8 that bumps that 0 to a 1. So what did I do? 24 divided by 5 is 4.8. I could write that 4.8 and take a square root of it here. Second square root 4.8, enter. And that is our standard deviation. This tells us how much it spread. The data spread from the mean. Okay, so let's look at test grades and find the range and the standard deviation. So we already have them in the correct order. So our range this time is going to be 100 minus 57, which is 43. Our mean, this one here, is going to be 57 plus 61 plus 71 plus 75 plus 80 plus 84 plus 85 plus 88 plus 95 plus 100 divided by our n is what? How many grades do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So divided by 10. And now we're going to remember to divide it by 10. Okay, 57 plus 61 plus 71. And be careful that you are actually pressing every number correctly. So check it on the calculator. 88 plus 95. Oops, let's see what happens. 95 plus 100. I'm going to hit enter here. And now I'm going to divide by 10. So the mean is 79.6. 79.6 is our mean. Okay, next we're going to do that table again, where we're going to list x, the mean, so this one, subtracted from the x, and then that squared. So our data, 57, 61, 71, and you cannot calculate this standard deviation without listing these here. There is no way you're going to be able to do all of this in your head and keep it in your head. Okay, 79.6. So we're going to do 57 minus 79.6, and that will be negative 22.6. Again, this one's larger, so it has to be a negative. And then we're going to subtract all of these. So 61 minus 79.6, and that's going to be negative 18.6. 71 minus 79.6 is going to be negative 8.6. Negative 4.6. 0.4. This one's 4.4, so that one's 0.4. 85 is going to be 5.4. 88 is 8.4, 15.4, and 20.4. And again, if we add all these, we get a 0. Now we're going to take these numbers and square them. Negative 22.6 squared. Or if it's not exactly a 0, it is very close to a 0. So it might not, because we have these, 0.4s here. It might not be exactly, but it'll be very close to it. Okay, so now we're going to square. So when we do this, and now do not remember or don't forget to put that negative sign in front. And actually, watch what happens. I'm going to press this x squared and hit enter. Well, it gives me a negative number. It shouldn't. So the mistake that I made is that I didn't put those parentheses. So it thinks that the negative is outside of that squared. So it should, so I'm going to put parentheses negative 22.6. Close the parentheses, squared, and I get 510.76. And it should be a positive because we're squaring. We're multiplying two negatives, and that should give us a positive. So do not forget that, those parentheses. So the same thing, negative 18.6 squared, and we get 345.96. Our next one is 73.96, 21.16. Again, make sure that you do these calculations on as you go so that you know how to do these. 70.56, then we have 237.16, and we have 416 and 16. And now what we need to do is we need to add all of these numbers. So all of these, when we add, we get 1,724.4. So this here is again our sigma x minus the mean squared. The sigma means that we're adding all these, and that's what we did. We added, and this is that number. So when we go and do the standard deviation, again, yes, the formula looks like this. But now we don't have to do this part anymore because we already have it up here. So this is 1,724.4. And then we did the n as well. N is 10. So 10 minus 1, and we take a square root of this. 10 minus 1 is 9. 1,724.4 divided by that 9, and a square root of it, we get 13.842. So how do you do it on a calculator? 1724.4 divided by, that needs to be inside the parentheses unless you do 10 minus 1 is 9 and just do it, equals. So this is 191.6, a square root of that. You can use the answer if you know how to do that, but second, the square root. And I don't want the, hold on. I used the wrong square root. This is the square root that I want to use, the x squared, not the one that is that's not a square root. 191, oops, and I'm missing the 191.6 equals, and we get this as a rounded number. So this is our standard deviation. Okay, so now what I want you to do is I want you to go ahead and do the calculation for these next two. I want you to pause the video because I'm gonna move forward. I'm gonna show the correct answers, and then I'm gonna discuss the C and D. But I want you to pause and do those yourself because you will have a standard deviation question on the test, and you need to show your work. So here are the answers. So we get a standard deviation of 1.581 and a standard deviation of 1.581. Even though if you look at our mean, this mean is 3 and this mean is 18, but still the standard deviation of these two is going to be the same. So it's the next question is, what do you notice about the standard deviation of each data set? Well, it is the same. And then if we draw them on a number line actually over here, so C is same, and then we graph them on a number line. They look very similar. If you look at these numbers here, the numbers are different, but the data, how the data is spread is similar. So that means that if you have the same standard deviation, your data, it doesn't matter what the numbers are, it's gonna, the way it's graphed on a number line will look very similar. Okay, number 4 actually has our the data sets from our first page here. So it has these data sets and it's asking you to calculate those standard deviations. So what I want you to do is I want you to go ahead and do that. Pause the video again because I'm going to show you the correct answers. So pause the video, calculate the standard deviations, and then as you've done them, check them against my calculations. So here are my calculations for that standard deviation, number 4. We had already calculated, and I can't get the, let me see, here we go. We had already calculated the mean on that first page here. Here are the means for those. So all we needed to do was, calculate the differences, square the differences, and then calculate the standard deviations. So what happened here was, I don't know how I used the opposite, but the standard deviation for this one is 2.882. Standard deviation for this one is 1.871. And the standard deviation for this one is 1.664. So for number 5, we're going to look at the number lines here. We're going to look at the number lines and which data set was more spread out or farthest from the mean on average. So if we look at which one was more spread out, it is A. A is the one that is more spread out. Well, did it have the largest or the smallest standard deviation? So if we compare the standard deviations, it had the largest standard deviation. Number 6, again, look at your number lines. Which data set was closer together? So closer together, if we look at it, the C is the one that is the closer together. And I didn't actually, you know what? Let me do this. So this is A, B, and C. A, B, and C, because that's just the easiest. So C is closer together than the others. So now if we compare the standard deviations, well, C standard deviation is the smallest. Deviation, there should be an I here. Okay, next, number 7. Find the standard deviation for the data set below. So I guess I'm going to go back to number 5 and 6, sorry. So the more it is spread out, the larger the standard deviation. The closer the data is, the smaller the standard deviation is. So our standard deviation tells us how much it's spread. So let's look at this data. So we have 9, 9, 9, and 9. We have our n is 5. And now you can calculate the mean, but it's going to be a 9 because we only have that number. So if we start doing our little table that we've done here, we notice that we have 9 fives. Well, 9 minus the mean, 9, that's a 0. So all of these are zeros, and when we square a 0, we get a 0. So all of these are going to be 0. So what's our standard deviation? If this, and we add all these up, it's a 0. So 0 divided by 5 minus 1. So 0 divided by 4, square root of that. Well, 0 divided by 4 is a 0, so our standard deviation is 0. So if all the numbers are the same, your standard deviation is going to be 0 because it's not spread. It's in that one spot. So remember, A is more spread out. It's the larger standard deviation. So because all the numbers are in the same spot, your standard deviation is 0. So now on number 8, you're supposed to create another data set with the same standard deviation. Well, you pick a number. It doesn't matter. It can be 125. And it doesn't even matter how many of these you have. Your standard deviation is going to be the same because it's the same number. They're in that same spot and not spread out. So that's it for this lesson. I know that I skipped some of those calculations. I just showed them to you. So if you have any questions about, please do not hesitate to email me about those calculations. Bye.